What?
on your iPad.
Oh, that's silly.
Your
Okay.
name.
Oh, come on.
All right, the mean value theorem, right? Basically, what it's saying here is instead of finding the area underneath this curve exactly, what it's saying is that there is some place that I can put this line here so that I get a rectangle so that it splits so that I will actually get the area underneath there. Okay, so you can kind of see how this part would actually fit in here, right? Now,
So it's where the area of the curve like changes.
all right, so you end up getting this little formula out here, okay, for that guy. All right. Now, notice that the mean value theorem does not specify how to determine what C is. It merely guarantees that it exists somewhere in there. Okay? So it's kind of a, drawing it is kind of a crapshoot. Right? But you know that it's got to be there.
But it's going to have to change directions. It can't be like just a parabola or...
No, like there, under any curve, even if it is a parabola, there will still be some place in there that I can draw a rectangle within the interval that I'm given that will give me the same perfect area that that would have been underneath the curve.
Okay.
Okay, so you're not real sure where it's always going to be, but you know that it will be in there. Okay, now the definition of the average value of a function, right? That's where we can actually try to start figuring out where that line is, right? So you've already seen everything from this point on anyways, right? That's what you guys were dealing with yesterday.
Yeah.
So if you want to find the average value of a function, you just plug a 1 over b minus a out in front of it, and you're all set.
Oh, bang.
Okay, so it's not that hard at all. So let's try this one. Find the average value of f of x on f of x equals 3x squared minus 2x on the interval 1 to 4. Okay, so we've got from 1 to 4 of my 3x squared minus 2x dx.
So is that 4 squared 16 times 3 minus 8?
Well, take the integral of this.
X to the third.
Okay, x to the third. And then if I brought down my 3, it is actually there. Right? That's not how we had been doing it. We had been breaking this up so that this was 1 to 4 of 3x squared minus 1 to 4 of 2x. Right? And then I'm allowed to bring this out in front and this out in front, so I get a 3 outside of my integral minus.
Both those are perfect, the ones that come out.
Yeah, it comes out nice. Right, so then we're just used to like dealing with this one, so the integral of that would be x cubed, but there's no 3 out there, so it'd be over 3. But there actually is a 3 out there, so they cancel. Okay. Minus this one, the integral of x would be x squared, but I put it over the 2 to compensate, but I actually had the 2 out there, so those cancel. So I end up getting x cubed minus x squared, and I'm supposed to find that from 1 to 4.
Let's see.
Just doing your head.
If you can do it in your head, that's fine, but that's the way we have been doing them.
Okay.
Okay. So I plug in my 4 there, 4 cubed.
64.
Okay.
Minus
Minus
16.
16, and then I have to subtract, plug 1 in there,
Or 0.
right, because it's going to end up being 1 minus 1. So I'm going to get 0, so 64 minus 16.
40. No.
38.
48, you're right.
48.
All right, so I get 48. But if we want the average value of that, then I still have this out in front. So 1 over a b minus a. What's my b? What's my a?
What?
So
1/3 of 48, which is 16.
Yep. There you go. Pretty easy.
Can you scroll back up?
Mm-hmm. How high do you want to go?
All the way back.
Over.
Just trying to think. Okay. I'm good.
Okay. How about finding the average value of the function of the given interval for all values of x in the interval for which the function equals its average value?
It's going to change at 0.
Well, first we're going to have to find its average value. Okay, and then we're going to take that average value and set it equal to its function to figure out where those would actually be. Okay,
That's obvious.
is it?
I want to say it is, because it changes directions at 0.
Yes, but it's the area under the curve.
Okay.
I don't know, we'll see.
All right.
All right, well, if I take the integral from -3 to 3 of this, right, of my 9 minus x squared, all right, what's the derivative of, or what's the antiderivative of that?
9x.
Minus x cubed over 3.
Okay, and then I need to take that from -3 to 3. So if I plug 3 in here, I'm going to get 27 times, or 9 times 3, which is 27, minus 3 cubed over 3,
9.
minus, if I plug -3 in here, I'm going to get,
-27.
and -3 cubed
-27.
divided by 3, and I'm subtracting that,
Oh. Okay.
right?
Yeah.
Okay. All right, so I got 27 minus 9 minus a -27 plus 9. Well, 27 minus 9 is
18.
18 minus -27 -18. So when I add the opposite, I'm going to get 36. All right, but they wanted the average, so that I have to take that 36, 1 minus a b, 3, minus a -3.
Plus 1 over 6. So that's what, 6?
Okay, and they want to know when, it says find the average value of the function over the given interval, and I want to find all the values of x in the interval when the function actually equals its average value. So what am I setting equal to x here? Or 6, I'm sorry.
0?
Nope,
Nope.
that would make sense.
X.
Oh, for crying out loud.
F of x.
F of x. That's what
That's
I'm.
what I meant.
So this is going to get a 6 put in for it, and then I want to know what x is when it's 6. How many will I have? 2. Okay.
0, -0.
6 will equal 9 minus x squared.
I'm still in the game.
Subtract 9 from both sides. I get 3 equals, or -3 equals -x squared. So
Oh,
3
I'm
equals
wrong.
x squared. Take the square root. When will it be 6?
Square root 3.
Radical 3 and negative radical 3. That's 0, right?
It's a reverso world.
Dang.
These make sense?
Yep.
Yeah.
8 through 32 multiples of 4. It's not that many.
I can't do that math in my
Really? And then 43 through 50 all.
Alright, so it's what? 8, 12, 16, 20, 24, 28, 32, so 7 problems.
Wow. You're an AP Calc student.
And you're an AP
Thanks,
teacher.
Thanks for showing me. Thanks for showing me why we selected you. All right.
You, 'cause